Most developers do not hate deployments. They hate the uncertainty around deployments. Will the build pass? Did someone forget an environment variable? Will a tiny change break production at 5 p.m. on a Friday? That uncertainty is exactly what CI/CD is designed to remove. In this video, you will learn what a CI/CD pipeline is, how it works, and how to think about building one for a real DevOps workflow. We will keep it practical, beginner-friendly, and focused on the mental model you need before touching tools like GitHub Actions, Jenkins, GitLab CI, Circle CI, Docker, Kubernetes, or AWS. By the end, you should be able to look at any modern software project and explain how code moves from a developer's laptop to production safely, automatically, and repeatedly. Let's start with the problem. Imagine a small team building a web application. One developer fixes a bug. Another adds a login feature. A third updates a database query. Everyone pushes code during the day, and at the end of the week, someone manually copies files to a server. That might work for a tiny hobby project, but it becomes risky very quickly. Manual deployments are slow. They depend on memory. They depend on one person knowing the right commands. They make it hard to repeat the same process every time. Worst of all, they make it easy for broken code to reach users. CI/CD replaces that manual process with an automated pipeline. The pipeline is a sequence of steps that runs every time code changes. It checks the code, builds the application, tests it, packages it, and when everything is healthy, deploys it to an environment. Think of it like an airport security system for your code. Every change goes through checks before it is allowed to board the plane to production. The first half is CI, which stands for Continuous Integration. Continuous integration means developers merge their code into a shared branch frequently, and every merge triggers automated validation. The goal is simple: find problems early. Instead of waiting until Friday to discover that 5 features conflict with each other, CI catches issues as soon as code is pushed. A typical CI workflow starts when a developer opens a pull request or pushes to the main branch. The pipeline checks out the code from the repository, it installs dependencies, it runs formatting or linting checks, it runs unit tests, it may run security scans. Then it builds the application to make sure the project can actually be packaged. If any step fails, the pipeline stops. That failure is not a bad thing. It is the pipeline protecting you. A failed build is much better than a failed production release. Now let's look at CD. CD can mean continuous delivery or continuous deployment. Continuous delivery means the application is always in a deployable state, but a human still approves the final production release. Continuous deployment means every change that passes the pipeline is automatically deployed to production. Both are useful. The right choice depends on the team, the product, and the risk level. For a payment system, you might want manual approval before production. For a documentation website, automatic production deployment might be perfectly fine. The important idea is that deployment becomes repeatable. You are not inventing the release process every time. You are running the same trusted workflow again and again. Now let us walk through a simple CI/CD pipeline from beginning to end.
Step 1 is source control. Your code lives in a repository, usually GitHub, GitLab, Bitbucket, or Azure repos. Every change starts here. A developer creates a branch, makes changes, commits the code, and opens a pull request. The pull request is not just for human review, it is also a signal to automation. Step 2 is the trigger. A trigger tells the CI/CD system when to run. Common triggers include a push to a branch, a pull request, a release tag, or a scheduled time. For example, you might run tests on every pull request, build a Docker image when code merges into main, and deploy only when a release tag is created. Step 3 is the build environment. The pipeline needs a clean place to run. This could be a cloud runner, a self-hosted runner, or a build agent. The keyword is clean. You want the pipeline to prove that the project can build from scratch, not just on one developer's laptop. Step 4 is dependency installation. Most applications rely on packages, libraries, or modules. A Node app might run npm install. A Python app might install requirements. A Java app might use Maven or Gradle. This step prepares the environment so the code can be checked and built. Step 5 is quality checks. This is where the pipeline starts acting like a gatekeeper. Linting checks whether the code follows rules. Formatting checks whether the style is consistent. Type checks catch certain classes of mistakes before runtime. Security scans can look for known vulnerable dependencies or exposed secrets. Not every project needs every check on day 1, but every serious project needs some automated quality gates. Step 6 is automated testing. Tests are the heart of CI. Unit tests check small pieces of logic. Integration tests check whether services work together. End-to-end tests simulate user behavior. Smoke tests check whether the application starts and responds at a basic level. The more confidence your tests provide, the safer your deployments become. But there is a balance. If your pipeline takes an hour to run, developers may avoid using it. A good pipeline gives fast feedback first, then runs deeper checks where they make sense. Step 7 is packaging. Once the code passes checks, it needs to be packaged into something deployable. For many teams today, that means building a Docker image. A Docker image contains the application, its runtime, and the instructions needed to run it consistently across environments. The pipeline builds the image, gives it a version tag, and pushes it to a container registry. That registry could be Docker Hub, GitHub Container Registry, Amazon ECR, Google Artifact Registry, Azure Container Registry, or another option. Step 8 is deployment. Deployment means taking the packaged application and running it in an environment. That environment could be a development server, a staging environment, or production. In a simple setup, deployment might copy files to a virtual machine and restart a service. In a modern cloud-native setup, deployment might update a Kubernetes deployment, roll out a new container image, and monitor whether the new pods become healthy. Step 9 is verification. This is the part many beginners forget. Deployment is not finished when the command succeeds. Deployment is finished when the application is healthy. The pipeline should check whether the service is responding, whether health checks pass, and whether the new version is actually running. If something goes wrong, the system should make rollback easier. Now let us turn this into a real example. Suppose you have a small web API. When someone opens a pull request, the pipeline runs a linting and unit tests. When the pull request is merged into main, the pipeline builds a Docker image and pushes it to a registry. When a release is created, the pipeline deploys the image to staging. After someone approves the release, the same image is promoted to production. Notice the phrase, the same image. That matters. You do not want to build one artifact for staging and a different artifact for production. You want to test the exact thing that will eventually run for users. This is one of the most important CI/CD habits. Build once, promote the same artifact through environments. Now, here are the mistakes that usually break beginner pipelines. Mistake 1 is putting secrets directly in the pipeline file. Never hardcode passwords, tokens, API keys, or cloud credentials into your repository. Use secret managers or the built-in secrets feature of your CI/CD platform. Mistake 2 is skipping tests because deployments feel urgent. That is exactly when tests matter most. If your test suite is slow, improve the test strategy. Do not remove the safety net. Mistake 3 is using different steps for staging and production. If staging deploys one way and production deploys another way, staging is no longer a reliable rehearsal. Mistake 4 is not versioning artifacts. Every build should be traceable. You should know which commit produced which artifact went to which environment, and when it happened. Mistake 5 is ignoring rollback. A deployment plan without a rollback plan is only half a deployment plan. Before you automate production releases, know how you will recover if the new version fails. So which tool should you start with? If your code is already on GitHub, GitHub Actions is a strong beginner choice because it lives directly inside the repository and has a large ecosystem of reusable actions. If your company already uses GitLab, GitLab CI is very integrated and powerful. If you are working in an older enterprise environment, Jenkins is still common and extremely flexible. If your focus is cloud-native delivery, you may eventually explore Argo CD, Flux, Helm, Terraform, and Kubernetes-based deployment workflows. But do not start by chasing every tool. Start by understanding the pipeline. Source control, trigger, clean runner, install dependencies, check quality, run tests, build artifact, store artifact, deploy, verify, roll back if needed. That pattern matters more than the logo on the dashboard. Here is a simple mental model you can use. CI answers the question, is this change safe to merge? CD answers the question, can this change be released safely? Observability answers the question, is the released change healthy in the real world? A mature DevOps workflow needs all three. If you're building your first pipeline this week, keep it simple. Create a repository, add one workflow that runs on every pull request, install dependencies, run one lint command, run one test command, then add a build step. Once that's stable, add Docker packaging. After that, add deployment to a non-production environment. Only automate production when you trust the earlier steps. That is how you build confidence without creating chaos. Before we finish, here is the revenue-focused lesson for anyone learning DevOps seriously. CI/CD is not just a technical skill, it is a business skill. Companies care about faster releases, fewer outages, better developer productivity, and safer production changes. If you can design and explain pipelines clearly, you can create value as an engineer, freelancer, consultant, trainer, or content creator. That is why this channel will focus on practical DevOps systems, not just tool tutorials. In the next video, we can build a real GitHub Actions pipeline step by step, starting from an empty repository and ending with automated tests and a Docker image. If you want that tutorial, subscribe, save this video, and comment pipeline. And remember, the goal of CI/CD is not to deploy recklessly. The goal is to make every release boring, repeatable, and safe.